Hi everyone, I wanted to just put a quick video together on how to plot parametric curves using GeoGebra. If you haven't got your own copy of GeoGebra yet, go to www.geogebra.org and grab yourself a free copy of the software. It's quite straightforward to install, and so once you get that done, then you can continue on with the rest of the video and play along with us. So just to start off the example, let's suppose we want to plot this parametric curve, the curve defined by x equals cos of t and y is sine of t over the interval where the parameter ranges from 0 to 2 pi. In GeoGebra, the syntax is as follows. We use a curve command, and within that curve command we specify all the bits and pieces. So the curve command is followed by a square parentheses and it ends with a square parentheses, and what's enclosed is first the x function and the y function. So in our example that would be cos of t and sine of t. And then we have to specify the parameter. This is the variable t. And then the interval on which the parameter ranges over. So the start at 0 and the end at 2 pi. So let's go ahead and fire this into GeoGebra. So once you have GeoGebra open, go down to the input bar in the bottom left corner and you can just start typing the command curve. And you'll see that it starts to autocomplete, and you can maybe find the expression you want. Here it's highlighted, so now I'll hit enter. And expression 1, well, that was going to be cosine of t. Expression 2, that's what we want it to be, sine of t. The parameter is t, the start value is 0, and the end is 2 times pi. And now we can hit enter, and now it's sketched the curve. So that's basically it. That's basically it, just sketching curves in GeoGebra. You can go back up here and say object properties, and maybe you want to change the color, so you can go in here and change the color. Style is where you can change the thickness. Maybe you'll make it 5-point thickness. There's a little label here, A. You can get it to hide that label by just right-clicking on the curve and saying uncheck this show label. So there's just a few fine-tuning features that you can do, but basically this is it. If we want to go ahead and change the description, we can double-click on the curve in this algebra window. It'll open up a dialog box, and we can then modify the curve here. Maybe I'll say it's cos of 2 times t and sine of, I don't know, let's say 6 times t, and there it updates. One of the things I like to do is I like to actually define my curve in the following way. I like to specify a function for the x function first. So I'll say f of x is, let's say, cos of t, and I'll hit enter. It'll plot it. So what I want to do is I want to hide it, so I can just hover over the little ball next to the function and click it, and that'll hide it. I can do the same thing for g of t. And it'll plot it as well, so now I'll hide it. And then I can go ahead and redefine my curve so that I'll tell it to use f of t as the x coordinate and g of t for the function defining the y component. Now it took 4 lines versus 1 line, but here it allows me to just quickly go in and edit the function itself. I like this a lot better just because I feel like I have good control over the functions and I can visualize in the algebra window what exactly is going on here. So maybe I'll make that a 10 times, and so there it updates. Okay, so I'll just reset it back to cos of t and sine of t. One of the other things we might be interested in doing is plotting the tangent line to a point on the curve. So let's go ahead and start typing tangent in the input window. And we see that one of the options that come up is tangent, point on curve, curve. Well, that's great. That's exactly what we want. So what point on the curve? Well, maybe I'll do the point corresponding to the parameter pi by 4. So the point on the curve, I can use the curve name. If we go back up to the place where the curve's defined, we see that its name is A. So I could use that in the command. I can say A of pi by 4. What's the curve? Well, I want it on curve A. And there's our tangent line. Now here's the fun thing we can do. Let's suppose I wanted the curve at another point. Actually, let's suppose I wanted to just be able to construct the tangent line to any point on the curve. Well, what I can do is, instead of making pi by 4 sort of a static number that I can't change, I'm going to use a variable to store pi by 4 in. I'll call that capital T. And then I'll go up to my line, and I'll change that pi by 4 to capital T. So far nothing's have changed, except now that if I go up to where I defined this variable capital T and I right click on it, I can get it to show the object. And what it does is it shows capital T as a slider. And now I can modify the value of T. So I can start dragging T around. And it automatically constructs the tangent line at any value of T. Now I can do one more thing, and that I can actually plot the point it's constructing the tangent line at by just using A of T. Remember, A is the curve. So what this is doing is it's taking the curve, plugging in the value of T into the curve, getting the X and Y values out, and it'll plot the point. And now I can drag the slider and have the tangent line update. And what's more is I can do things like, well, I can modify the function. Maybe I'll say cos cubed and sine cubed, and everything updates along with it. And that point can still move around the curve, and I can still construct the tangent line. So just some fun things you can do as you play around with GeoGebra. All right, well, that's it for how to sketch curves, parametric curves in GeoGebra. Go ahead, have some fun, try it out for yourself, and see what kind of pictures you can come up with.